Alright, this is it right here. Trying to get this JavaScript developer certification. And yeah, let's go for it. Okay. Congratulations on taking the next step to prepare for your Salesforce JavaScript Developer 1 exam. This exam guide has the information you need to help you study and prepare for your exam. Let's get started. Okay, let's see. The Salesforce Certified JavaScript Developer 1 credential is intended for individuals who have knowledge, skills, and experience developing front-end and/or back-end JavaScript applications for the web stack. These skills can be applied to any framework and are not mobile or device specific. The credential validates both core JavaScript skills and hands-on development skills of candidates who need to work with JavaScript-related technologies like the Lightning Component Framework and specifically Lightning Web Components. Lightning Web Components are custom HTML elements built using standard HTML in modern JavaScript. The certification consists of two parts: the JavaScript Developer 1 proctored multiple choice exam and the Lightning Web Components Specialist Super Badge. These two credentials can be earned in any sequence. The multiple choice exam focuses only on JavaScript, and the Super Badge covers the hands-on Lightning Web Component development skills. The combination of both these credentials automatically earns the Salesforce Certified JavaScript Developer 1 credential, which is what I'm trying to get, so we are going to aim at getting this. Let me turn the brightness in the background up a little bit. Hold on. Alright. Let's connect. There we go. Alright. Audience description, the Salesforce JavaScript 1, Developer 1. The Salesforce Certified JavaScript Developer 1 certification candidate uses the JavaScript language and one or more frameworks to develop front-end and/or back-end applications. The candidate can design, develop, test solutions that are performant, maintainable, and reusable. Candidate can use JavaScript-specific design patterns for programming and combine JavaScript with CSS, HTML, and other markup languages. Every JavaScript developer can easily build on Salesforce with Lightning Web Components. For the millions of JavaScript developers worldwide, this means they can code on Salesforce without having to learn anything new. Alright, developers can use the existing portfolio of developer services in the Lightning platform and modern JavaScript language to build and deploy blazing fast apps on Salesforce. Okie dokie. Salesforce Certified JavaScript Developer 1 is intended for Salesforce partners, customers, employees who work with JavaScript and also have knowledge, skills, and experience with the Lightning Component Framework developing Lightning Web Components. Typical job roles that align to the Salesforce Certified JavaScript Developer include JavaScript Programmer, Salesforce Developer, Full Stack Developer, Web Application Developer, Front-End Developer, Software/Backend Developer, Support Engineer, Technical Project Manager, UX, UI Engineer. Alright, the exam guide is designed to help you evaluate if you are ready to successfully complete the Salesforce JavaScript Developer 1 exam. The guide provides information about the target audience for the certification exam, recommend training and documentation, and a complete list of exam objectives, all with the intent of helping you achieve a passing score. Salesforce highly recommends a combination of on-the-job experience, course attendance, and self-study to maximize your chances of passing the exam. Okay. JavaScript Developer Certification Exam is an industry standard credential in the JavaScript ecosystem. The credential is intended for individuals who have 1 to 2 years knowledge, skills, and experience developing front-end or back-end JavaScript applications for the web stack. This exam validates core JavaScript development skills of candidates who need to work with JavaScript-related technologies. A huge benefit of the Lightning Web Components programming model is that developers write standard JavaScript code. Candidates who pass the JavaScript Developer exam demonstrate that they have the standard JavaScript fundamentals to develop Lightning Web Components. There is no prerequisite certifications for this exam. Read on details about the Salesforce JavaScript Developer exam. Content, 60 multiple choice questions and up to 5 non-scored questions. Time allotted to complete the exam 105 minutes. Passing score 65%. Ooh, registration fee is $200 plus tax. Retake fee $100 plus tax. Delivery options: proctored exam delivered on site at a testing center or in the online proctored environment. Click here for more information on scheduling an exam. Okay, cool. Recommended training resources. It generally has 1 to 2 years JavaScript developer and has experience with the following topics: data types and operators, variables and variable scope, string manipulation, type coercion and conversion, functions, data structures, inheritance, classes, modules, DOM, events, error handling, debugging, testing, asynchronous programming, server-side JavaScript. As preparation for this exam, we recommend a combination of hands-on experience, training, course completion, trailhead trails, and self-study in areas listed in the exam outline section of this exam guide. The self-study materials recommended for this exam include learning on Trailhead, Trail Mix, prepare for your Salesforce, blah blah blah, Trail blah blah, community. Okay. Okay, here's a breakdown of the questions. Okay, cool. Okay. Okay, sweet. So that's kind of a breakdown of all that. Now let's go back here. Or go back here, I should say. I have completed that. Okay, here we go. 600 points. Let's do this module. Okay, 10 minutes on this. Okay. Alright. After completing this unit, you'll be able to describe the nature of JavaScript runtime environment, distinguish between the JavaScript engine and the language, avoid key pitfalls when learning JavaScript, describe some important JavaScript best practices. That looks like what we're going to do. Alright, the what, why, how of JavaScript. In the early 2000s, the software world was exploding with the idea that you can build applications that were hosted and delivered entirely over the internet. Although we take web applications for granted now, at the time they were as mind-blowing as seeing a robot ride a bike. Browsers were simple HTML renderers, and HTML and JavaScript standards were fragmented. To create a web page with even mildly complicated functionality, you had to force users to use only one browser, usually Internet Explorer. Even today, there are apps that force this because design decisions made in this era. To work around some of these limitations, server-side UI frameworks evolved to allow software developers to dynamically create web pages on servers. Complex logic executed where the computing power was, on the server. Rendered HTML was then served to the feeble browser. In this world, JavaScript was primarily a way to make pages somewhat interactive and to execute rudimentary logic without a server trip. Server-side frameworks were extremely popular, including the Salesforce framework Visualforce. As testimony to this popularity, there are millions of Visualforce pages live in Salesforce today. Fast forward to the present, and the world is a different place. Browsers are powerful applications that optimize web page viewing. JavaScript is well standardized around the ECMAScript standard, and top browser manufacturers are generally good about adopting new features. Web applications today have rich user interfaces running modern JavaScript in the browser, instead of server-side frameworks, modern web applications tend to be client-side rendered. In Salesforce, this is done with the Lightning component framework, but writing JavaScript is still new for many developers. If you've worked mostly with Visual Force pages and Apex controls, you might need to leg up and really get how JavaScript works so you can better understand your components. Time to level up your JavaScript skills. Okay, cool. The JavaScript runtime is an engine that interprets JavaScript code. It can be part of a browser and other runtime environment like a server. Modern JavaScript engines are sophisticated and powerful to optimize execution and designed to conform to the ECMAScript standard. The defining feature of JavaScript engine is single-threaded runtime represented by the stack below. Work being done in the stack owns the thread and must complete its synchronous logic before it hands back control of the thread. Okay, events, API, stack, queue. Okay. The runtime is a busy place. New work can come in at any time from number of origins including the user, UI events, and web APIs such as geolocation or device motion. Since there's only one thread, there is a queue where work awaits its turn to use the thread. When the stack is empty, the event loop takes work that is waiting to be done from the queue and moves it into the stack. This, of course, is a simplification but illustrates the basic model of how JavaScript engine gets work done. The JavaScript language works the way it does in practice because of this architecture. JavaScript, the language. As a language, JavaScript is frequently misunderstood. If you picked it up for a length of time, you've undoubtedly asked yourself questions. Is it a scripting language? What does it have to do with Java? Is it a real programming language? Why does it do that? Let's set some context around JavaScript as a language and help you answer some of these questions. JavaScript is changing because JavaScript is built according to the ECMAScript standard. It's constantly changing. An update to the standard describing new features is published every year. Then JavaScript engine projects put them in place. Updates can include more modern language features as JavaScript matures. In other cases, features are added to implement cleaner syntax for existing functionality. They are called syntactic sugar. Okay. Adoption of APIs is not universal. This statement may seem scary, but the vast majority of JavaScript APIs work in the most common browser platforms. Still, implementers don't adopt every language feature or API at the same rate. Some never adopt certain features, although this is rare. In general, if you want to use a new feature of the language, you should understand how well it will work in your target browser using a resource like caniuse.com. If a new feature isn't implemented natively, there's often a bit of code written to temporarily serve the purpose of that missing feature. This temporarily filling code is called a polyfill. In fact, the Lightning component framework uses a curated list of polyfills that are applied before other code is run to automatically improve browser compatibility. Okay. Indispensable things to know. It's time to look at some code. Let's start with some things every JavaScript developer should know that makes their lives easier. Remember, case sensitive. JavaScript is case sensitive. This is tricky for many Salesforce developers who are used to both Apex and SoCool being case insensitive. Remember, anytime you write JavaScript code in Salesforce, be mindful of case insensitivity or case sensitivity. Declaring variables. Variable declaration is done using three operators: var, let, const. Okay. Alright. I was just here for the JavaScript history lesson. This stuff right here I'm pretty familiar with. So. But this is actually kind of good to review. Var scope, it's a function. Mutable assignment, yes. Let's a block. Yes. Const a block, no. Scope is a topic that we discuss later. Let's address mutability means. All variables are pointers. Assignment is the act of pointing that variable to something. Hold on, I need to go turn the fan down. I'll be right back. Hold on. Okay. Mutability is whether or not a variable can be reassigned once it has initially been assigned something. Using var or let creates immutable pointers, whereas const is immutable, as it is often the case. Okay. I need to make flashcards for JavaScript because I need to know all these things implicit type, just like the lingo. I can write it, but I don't have like a great fundamental understanding. Okay, for Boolean comparison, the best practice is the triple. Okay. Oh yeah, Boolean comparison. That makes sense, yeah. Alright. Mm-mm-mm. Okay. Implicit type coercion. You know that rule we just laid out about warning against implicit type coercion? Well, here's the exception. When an expression expects a Boolean value, the following values are treated as false. False as false, of course, the rest is false. As a group they refer to as falsy. There's no question that true is that just that true, but any other value of any type coerced to true, we call these values truthy. This has a handy side effect. Let's say you want to test for several types of invalid data by simply passing the variable into an expression. Okay, response I get value right. If I return this, for some reason the above assignment fails when we end up with an uninitialized variable, an empty string, or 0. We've covered all these bases. Doing the conditional check record. Hold on, I'm gonna play a little music in the background. Okay, if for some reason the above assignment fails, blah blah blah. Okay, so for testing purposes, single threaded, right? Pretty sure it's single threaded. Hold on. Alright, cool. Got 100 points. Actually, you know, I think I'm gonna try speed running this. I need to just go through this hella fast. Get this thing. Test, test. Test, test. Okay, that works. Okay. Okay, I got one watching. I think it's me though, but that's all good. Alright, let's go. How JavaScript works in the browser. Okay, cool. Boom, boom, boom. Shouldn't be surprising that there are APIs to interact with the browser, just like any other programming language, or platform surfaces APIs to interact with the environment it runs on. So too does your browser. Okay. Adding web APIs to the picture. Previously, we created a picture of the JavaScript runtime. Alright, request execute on the stack using a single thread. A request holds the thread until it's done executing all synchronous logic for the request. New requests are queued until the thread is ready. The event loop moves the next queued request into the stack when it becomes available. Okay. Okay, window serves the document, serves the body, blah blah blah. Okay, we'll just skip down these questions with the purpose of a DOM. Document object model. Okay. When a page is requested, then received by the browser parses the HTML and creates a description or a model of that page. This model is used to draw the page in the browser's viewport. It's also surfaced to JavaScript through the DOM. Think of the DOM as a tree. It starts at the root of the browser's display functionality, the window. From there, the page is encapsulated in window.document, with the page's body in window.document.body. Then the tree fans out to every bit of the content represented on the page. Most web pages have a very complex tree. Okay. Shadow DOM, I've never heard of this. DOM API is rich and flexible. Using relatively simple JavaScript, it is easy to make changes to looks, behaviors, and actions invoked by the UI. But there's a pitfall. The DOM model makes it difficult to encapsulate pieces of the UI and protect them from accidental or purposeful and malicious changes. Okay, for this reason, the Shadow DOM standard was developed. Shadow DOM creates a boundary around the particular part of the UI functionality. The boundary prevents a parent from changing the elements or CSS of a child. It also forces any events propagated across the boundary to rescope their targets, prevent the parent from reaching across the Shadow DOM boundary. Okay. Each unit from this point forward will have a similar section with some examples to illustrate the tie-in to Lightning Web Components. If you want to apply what you're learning, now is a great time to begin the Lightning Web Components Basics module on Trailhead. Okay. Alright, this component demonstrates this principle in its simplest form. This text came from a JS prop. Import Lightning from LWC. This text came from JS prop. Well, that's kind of cool. Lightning card component. Basic DOM example. The code above uses the JavaScript property text to store a hard-coded string. And there, okay. But what if you wanted the UI to change when the user interacts with it? We can extend this example to do just that. Here's the code. Handle change. Nice, you pass in the handle change function right there on the input. That's cool. Alright, in a Lightning Web Component JavaScript, class properties are reactive. This means when a property's value is assigned and the property is used in a template, the component's DOM re-renders the displays the new value. In the template, we added a Lightning input. Although binding the text properties is key in displaying the data, notice the onChange attribute. The handle change function that's been added to the JavaScript class now is triggered by change events. Okay. Let's see. Oh, this is cool. Nice. Okay, let's say I have 4 answers. Guess I'll just type it out. Oh, that's what I thought it would be. Automatic dominant manipulation? Hold on. Damn it, I hate when I accidentally hit enter. Did not mean to do that. I think it's going to be C is my guess. I know I got that first one right here, but I haven't written a JavaScript class in a long time. Alright, despite not having classes as defined by classical languages, JavaScript still has an inheritance model called prototype inheritance. As a prototype, in fact, it sits in memory, defines properties of functions that other objects inherit with their same prototype. When using functions as event handlers, what are the typical parameters in the function definition? Pretty sure it's just the event. Sweet. Let's go. Okay, I got this one right. Alright. In JavaScript, this refers to the context in which the function was called, which can vary depending on how the function is called. Method constructor. That makes sense. Whoa. Oh, ChatGPT was wrong. That's crazy. Oh, a function is declared. Okay. Pretty sure it's B. Okay. Writing secret in JavaScript, you'll be able to identify. JavaScript invoke function since the timeout. Engine is a single thread that does work, finishes, then we as all new work stuff occurs, critical that the thread not be blocked. Let's see this. Alright, callback is simply a function passed into another function that invokes it at some point in the future. So in reality, we've already seen a bunch of callbacks. Ooh. Oh shit. Which one am I supposed to do on here? I already have it installed. The fuck? The heck? Why did that not work? Why's my username wrong? Hold on. Okay, we got that. Okay, we have all that. After you authenticate, success message, cool. Create Lightning web component. Okay, where do I go to see this? Oh, open default work, okay. Okay, where's the edit button on this page? Okay. Where on here do you see an edit button? You can see this. But that's not for this. I need to edit this dashboard. Where's the edit button? Edit page. Okay, maybe there is edit page here. What the hell? Edit page. Dude, I don't see an edit button. Edit page. What the fuck? What's this thing? What's this? Okay, this is insane. Okay. Okay. Click on the gear icon top right corner, click setup, click the object manager tab. Okay. That's not it. Oh my goodness. Why did it have to be like this? Outdated. When was this page updated? Open. Okay. In Visual Studio Code, open the command palette by pressing Command Shift P. Did that. Did that. Okay. Oh, wow. This is it. In the app launcher, find and select sales. Okay, it literally says click this to edit page. There is no edit page. Damn, dude, this trailhead's outdated. Well, at least this works. Okay, at least I'm on something here. Let's see. Fuck. Where's my thing at? Hold on. Okay, here we go. Hello world. Alright, so hello world should pop up in this. Oh, nice. That's cool. Yeah. Default homepage. How do I add it to this default homepage? Bruh, this is so stupid. Literally no way to edit this page. Click the gear icon, hit edit page. I click the gear icon. There is no edit page. Why? Makes no sense. It's probably outdated. Unable to edit this home page. How am I going to pass the Salesforce stuff if I can't even get through this? This doesn't make any sense. We are stuck, folks. We are stuck. Holy shit. Google searching everything. Okay, I don't even know where my Salesforce module screen went. Freaking backed out of it. From the app launcher, select Sales. Click gear icon. Select Edit Page. Let's try it again. Alright. Click the gear icon. Oh my god. How? How? How does that work? I was just on this page just like 40 seconds ago, this exact page. Well. This is good. Now we can throw this in here. Or here. Save. Activate. Assign. Save. Save. Back. Cool. Now we go back here. Verify. Show me the goods. Give me 100 points. Let's go. Cool, 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 cool. Yep, I was messing up. Alright, cool. Got that now. $18 hours left on this. Let's go. Alright, let me stand. We'll take a little break. Alright. Command flag pass, command flag arguments, command flag numbers, command structure. Nice. Does. Sweet. With the badge. Oh man.
Version, it will show a message something like this. Yeah. So on my machine, this shows that it's already enabled and installed. Going back. Okay. So our next step is to log into the Dev Hub. Go back to your command prompt or your terminal, depending on which OS you're using, and fire this command. This will try to log you in on your playground. Yeah. Just click on login, put in the credentials that you had saved, and it will prompt you to allow access for the Salesforce CLI. Okay, so I'll click on allow, and that's it. Your authentication is successful. You can go back to command prompt, and you'll see that your user has been successfully authorized, and it will display the org ID. So now what happens with this step is Salesforce CLI remembers your Dev Hub credentials, and you can typically start working with the Salesforce CLI. Okay, so let's go back to our unit. Yes, we have successfully verified this step. Now we'll just go ahead and verify this unit, and it's done. Okay, so let's move on to the next step. Okay, so next step is setting up the project on your local machine. Okay, so first thing first, if you're a Windows user, then you'll have to first install Git for Windows. tooling that they have provided within this link. And yeah, then you can just follow the instructions that I'll be showing on in this session. Okay. Okay, so basically Salesforce in this particular unit, what we are going to do is there is this app, Dreamhouse app, which Salesforce has already hosted on this repository. So through the command line interface, we are going to try to pull this particular project on our local machine. Okay, and yeah, I'll just show you how you can do that. So let's copy the very first command. This is going to create a directory on our local machine. Yeah. Now we just simply switch to that directory using the cd command. Okay. Then next is to clone the repository which Painter has created. The one that I was showing you here, Dreamhouse. Okay. So here, after firing this get clone command, it's going to copy all the components that are present on this repository onto my local machine. Okay. So as you can see, it has completely cloned over all the components and it's done. Then next step is to open the directory. Let me just copy the command and put it here. Yeah, so we have now switched to the Dreamhouse directory. Then as the next step, we'll simply create our own branch so that we can continue with our work. And this is a kind of a best practice to follow whenever you want to make changes and put it on your Git repo. So yeah, so as you can see, my branch has been created, and with this command, we have switched to the new branch, my branch. Yeah, and that's it for this unit. So I'll just click on verify step and we are done. Now let's move to our last unit of this module, which is creating and test a scratch org. Okay, so yeah, we have already learned about what a scratch org is. So as part of this unit, we'll be creating the scratch org and we'll be pushing some metadata into it, following the commands that have been provided into this unit. So our very first step is to create the scratch org. I'll copy this command, sf or create scratch, and go back to my terminal window and execute it. Okay, so the process has started, and as in when it completes, it will keep turning on these labels to green. So right now we are on prepare request. It will take some time until all these steps are done. So let's wait for some time for this to complete. Okay, authentication done. Okay, great. So now our scratch of the Salesforce DX is it's a Salesforce product that allows users to develop and manage the Salesforce apps throughout the entire platform in a much more direct and efficient way. It provides set of tools to improve the traditional developer's experience of building on the platform. Now let's quickly understand some of the key terminologies that are used in this unit. First is the scratch org. Salesforce Scratch org is a temporary Salesforce instance typically used for a specific development. Each developer could have their own Scratch orgs to increase the productivity. This also means that developers can avoid bumping into each other while they are creating rapid POCs for the project. Yeah, and developer hub org. So a developer hub org is the main Salesforce org that allows you and your team to control the scratch jobs. Okay, so let's quickly launch the playground. Okay, okay. I'll go to setup. From the quick find, I'll search for dev hub. Go ahead and enable this setting, enable dev hub, and that's it. Once the setting is enabled, you can't disable it. Go back to the module. Then the next step is to grab the trainer username and password. So in order to grab the password, you need to go to your trainhead playground and click on get your login credentials tab and click on reset my password. Salesforce will send a link to your email address that is registered and you could reset your password from there. Just get a hold of your username and password and store it somewhere. We'll need it in some time. Then the next step is installing the command line interface. So you can go through the setup guide and follow the instructions to install the command line interface. Okay. Once that is done, I can show you how you can double check that. Open your command prompt and just fire the command sfdx update. So in case it's installed properly on your machine, in case it's properly installed on your machine, it will try to search for latest version if that is available. And if it's not available, if your system is already on an updated version, it will show a message something like this. Yeah. So on my machine, this shows that it's already enabled and installed. Going back. Okay, so our next step is to log in to the Dev Hub. Go back to your command prompt or your terminal, depending on which OS you're using, and fire this command. This will try to log you in on your playground. Yeah, just click on login, put in the credentials that you had saved, and it will prompt you to allow access for the Salesforce CLI. Okay, so I'll click on allow, and that's it. So your authentication is successful. You can go back to command prompt and you'll see that your user has been successfully authorized and it will display the org ID. So now what happens with this step is Salesforce CLI remembers your Dev Hub credentials and you can typically start working with the Salesforce CLI. Okay, so let's go back to our unit. Yes, we have successfully verified this step. Now we'll just go ahead and verify this unit and it's done. Okay, so let's move on to the next step. Okay, so next step is setting up the project on your local machine. Okay, so first thing first, if you're a Windows user, then you have to first install the Git for Windows tooling that they have provided within this link. And yeah, then you can just follow the instructions that I'll be showing on in this session. Okay. Okay, so basically Salesforce in this particular unit, what we are going to do is there is this app, Dreamhouse app, which Salesforce has already posted on this repository. So through the command line interface, we are going to try to pull this particular project on our local machine. Okay, and yeah, I'll just show you how you can do that. So let's copy the very first command. This is going to create a directory on our local machine. Yeah. Now we'll just simply switch to that directory using the cd command. Okay. Then next is to clone the repository which people have created, the one that I was showing you here, dream house. Okay. So here, after firing this get clone command, it's going to copy all the components that are present on this repository onto my local machine. Okay. So as you can see, it has completely cloned over all the components and it's done. Then next step is to open the directory. Let me just copy the command and put it here. Yeah, so we have now switched to the dream house directory. Then as the next step, we'll simply create our own branch so that we can continue with our work. And this is a kind of a best practice to follow whenever you want to make changes and put it on your Git repo. So yeah, so as you can see, my branch has been created, and with this command, we have switched to the new branch, my branch. Yeah, and that's it for this unit. So I'll just click on verify step, and we are done. Now let's move to our last unit of this module, which is creating and test our Scratch org. Okay, so yeah, we have already learned about what a Scratch org is. So as part of this unit, we'll be creating the Scratch org, and we'll be pushing some metadata into it, following the commands that have been provided into this unit. So our very first step is to create the Scratch org. I'll copy this command, sf or create Scratch, and go back to my terminal window and execute it. Okay.
I already did this too. Damn, I already did everything. I just followed the GitHub repo. Yeah, it looks like I'm done. That's cool. Yeah, I think I'm gonna take a break. Well, that's all we got. How many points do we have so far? We have 2,650 points. Sweet. All right. All right, we'll take a little break.